Earthquakes do a lot of damage to the building. For example, in 2010, O'Higgins Tower in Chile collapsed. It was built in 2008. The collapse was due to the architectural asymmetry and lack of continuous reinforcement. This made building more vulnerable to the strong lateral.
In this video, we will explain about the impacts of the 2000 Chile earthquake in aspects such as transportation, economy and social. The earthquake caused significant damage to the transportation hub. The epicenter was close to the main cities in Chile. 5 main locations that were badly affected were Santiago, Concepcion, Route 5 Highway, Arauco and suburbs of Concepcion. Liquefaction also plays a major role in the failure of bridges and highways. Liquefaction is a phenomenon where a saturated soil loses strength in response to an earthquake and behaves like a liquid. While in the economic sector, damage to fisheries was $66 million. The forestry industry, which accounts for 8% of exports, were horribly affected. Winemakers suffered too as storage tanks split open. Damage from the earthquake cost about $30 billion. The Chilean government built 500,000 new houses and repaired 1 million of the old ones.
Most earthquake-related deaths are caused by the collapse of structure, so it's vital for civil engineers to make structure more resistant to earthquake. One of the techniques used to make bridges more earthquake-resistant is self-anchor suspension span. The main tiles are in 4 pieces connected by shear links designed to absorb shock. Base isolation is a technique to minimize damage to buildings during an earthquake. An isolated base building rests on flexible bearings known as base isolator. These isolators absorb most of the seismic energy and reduce the acceleration of building during an earthquake, making a collapse less likely to happen. Another way to make buildings more earthquake resistant is the use of damping devices. Damping devices have high damping capacity, and by equipping these devices to buildings, we can reduce the shaking of the buildings and therefore decrease building damage. Bracing is a technique in which braces are crossed to form an X-shape to support a frame. These braces support compression and tension forces during an earthquake and reinforce the structure by having these diagonal support, making structure more resistant to earthquake.
Tailing dams are in many ways similar to water dams. These structures are put in place to form an embankment and create a deep artificial reservoir to contain the residue from mining. They can fail due to earthquakes, mudslides, or if the structure is weakly engineered and cause catastrophic damage. One of the causes of failure is liquefaction. Water can seep through the dam and weaken the internal structures, leading to a collapse in the wall, thus flooding surrounding areas with toxic waste and potentially leading to water contamination. More regulation is required so that the engineers responsible carry out regular assessments and inspections, making sure that any structural impairment is attended to immediately. In the short run, people die or get horribly injured, and often settlements are destroyed to rubble and residents are displaced, having to leave their village or town. Infrastructure suffers the most as a result of earthquakes. Electricity pylons, water and gas pipes and transport links are destroyed, restricting relief efforts and leaving people in need of basic supplies. In the long term, serious outbreaks of typhoid, cholera and waterborne diseases remain an inevitable possibility.
As you can see from this comparison between Haiti and Chile, with the good research about the behavior of earthquake, we can save a lot of lives and reduce the destruction.